By 2050, nearly half the world's population could be living in areas facing water scarcity. In 2026, the future is already taking shape, with billions experiencing water shortages. India, too, is facing growing water crisis, and the built environment has a very critical role to play. Buildings account for over 20% of urban water consumption, while simple solutions like rainwater harvesting can significantly reduce this demand. In this episode of Friday Frames, expert Vishwanath S explores sustainable rainwater harvesting and water resource management systems and how better design can help build a more water secure future.
As I was discussing with Geeta and she was and Sonam, and they were sending me questions, I thought, let's not make it about what I have done over 38 years of work, but more on understanding what rainwater harvesting is in simple terms and what it can do in terms of being incorporated into the designs we make as architects or engineers in our profession, as well as our personal life. So it's 101 on rainwater harvesting. So insofar as India is concerned, as was already pointed out, we are facing a water challenge. Let me not call it a crisis. It's a challenge. It's a design challenge. And there's enough solutions for us to be able to overcome the challenge too if we work in a concerted fashion. For cities, we have 7 taps, generally speaking. The 7 taps is piped water supply, which generally comes from a faraway source. Then there's rainwater, which actually falls on the city, which is now not being used enough. There's surface water, which stores this rainwater in lakes, ponds, streams, and rivers. There's soil moisture. We forget sometimes that soil moisture is a bank which supports plants and trees in our cities and in our villages. Then there's groundwater, water which seeps through the soil and reaches the aquifer, which is a body of sponge which holds on to water and releases it. And so this groundwater is in the form of springs, shallow aquifers, wells, deep aquifers, bore wells, which we can use. The next one is treated used water. Used water is wastewater or sewage, as it was called before, but now it's called used water. And increasingly, treated used water is seeing great merit in terms of solving part of the water challenge that we face in our urban areas and rural areas. And of course, the next one is desalination for cities and towns which are next to the sea, which are close to the ocean or the sea. Desalination is an alternative, though it's a bit energy intensive and costly. And the final one is a tap control, which is demand management and leak reduction, right? So demand management is crucial, of which rainwater is one component of what we will discuss today, right? So when rain falls in a city or in a village, this is how it falls. 65% of a city, if you take a look at it from a Google Earth photograph, 65% is rooftops of buildings, 50 to 65%. So there's rooftop rainwater. Then there's water which falls on roads, parks, open spaces, and other spaces which are not rooftops. And then that's collected in major stormwater drains. This runoff, if ideally designed, it's collected in major stormwater drains. So from rooftop rainwater, you can filter the water and store it, or you can filter the water and recharge the ground. From landscaped areas, you can pick off the runoff, filter it, biofilter it, and generally recharge the ground or make up soil moisture. And in major stormwater drains, you can actually allow the water to be collected in lakes, tanks, and rivers and wetlands so that it's then available for nature as well as for us once we move along in the year. And so for each city, we have to develop what we call an understanding of water balance at a site level. What happens on a small part of land, let's say a 30 feet by 50 feet site or a 10 meters by 20 meters site. In the context of Bangalore, when rain falls on the site throughout a year, about 10% of it runs off. You can see the figure on the left. 10% of it runs off and reaches stormwater drains. About 3 to 8% alone would recharge below 1 meter. And about 85% of the water would be held in that soil layer of 1 meter and be taken by plants and trees through their root systems and evaporated or evapotranspired, right? That is in an unbuilt condition, and I'm talking about a flat piece of land. The very same parcel of land, when it's built upon, when we put a house on it, the runoff now becomes 95%. So from 10%, we've gone to 95%. Recharge is virtually zero. And evaporation is because the roofs are heated up, about 5% evaporates, right? So we've dramatically altered the water cycle at a site level, at a plot level. Now, this varies from city to city. It varies based on the rainfall patterns that are there on the city, and it varies on the soil conditions. So for each city, we have to develop our own plot level understanding of hydrology. And this is for Bangalore broadly in general. So what happens? When the increased runoff from 10% to 95%, you see urban flooding. right? Because all the stormwater drains cannot handle the volume of runoff that is now coming, added to the fact that due to urban heat island effect and climate change, the intensity of rainfall is also now increasing. So we have urban flooding, and on the other hand, because there's no recharge, there is groundwater depletion. And this typically becomes a problem for the city to manage, because you have one hand, no water in your bore wells and open wells, and on the other hand, you have flooding, which you then cause physical and economic damage. So that's the broad number. So therefore, the aim of rainwater harvesting for me, in terms of design at a plot level, is biomimicry. Let's design the system to capture the excess runoff that we are generating, hold on to it, use it, and then release it to the environment so that it can be picked up and treated and reused again, right? So it's not that we grab onto all the rainwater that falls on the site, but we try to grab onto the share which has been increased due to the construction or building on the site itself. So what is rainwater harvesting? Globally, rainwater harvesting is understood as collection and storage of rainfall for future productive use. Yeah, you collect the rainwater in a stored tank and you reuse it. But in India, it's also understood as recharge of the aquifer. Yeah, whereas in the rest of the world, it's called managed aquifer recharge. In India, we call it rainwater harvesting also. So collection and storage, recharge of rain for future productive use. And what are the components of rainwater harvesting? There's a catchment, usually the roof. There's a conveyance system, the rainwater gutters and pipes. There's a filtration system, and I'll come to that. We need to filter the water from silt and sediments. Then there's the storage system, which you can have many kinds of storage systems. I'll discuss that. Then there's a recharge systems, and there are different kinds of recharge mechanisms available to us in terms of design based on the geology and soil profile of that particular area. So a complete system of rainwater harvesting. The blue drum is a filter. From the rooftop, pipe is coming, bringing the water down. The blue drum is filtering it. You store it in an underground sump tank. The overflow from the sump tank, if there be any during heavy rain, goes into a recharge well, which is the long pipe. And if the recharge well also fills up, then it goes to the stormwater drain to move ahead. A complete system of rainwater harvesting looks like that. And why do we do rainwater harvesting? Obviously, to biomimic it, not to cause urban flooding, to recharge aquifers. And in the case of many places which are fluoride, arsenic, and nitrate affected, if we hold on to rainwater for drinking and cooking purpose, it gives us high quality water, which is free from fluoride, arsenic, nitrate, iron, salinity, and others, right? So we need a small portion of our water consumption for drinking and cooking. And in places like Rajasthan and Gujarat, traditionally this has been used to substitute for A, water availability itself, but B, for also fluoride, arsenic, and groundwater contamination, right? And so what does rainwater harvesting depend on? There's some basic questions on it. It depends on the rainfall pattern of the city. In Bangalore, you have a bimodal peak, right? So there's a rainfall in March, April, May, where actually May is a very heavy rainfall month. Then it tapers off in June, July, again picks up in August, September, October. But many parts of India have rain in the monsoon season alone. That's to say from June, July, August, and September, 4 months of the year. So we have to study the rainfall pattern of our area to design rainwater harvesting systems. The other consideration is something called rainfall intensity. And intensity is the volume of rain that falls in an hour, measured as millimeters per hour. So we may have a rainfall intensity in Bangalore, which can go up as high as 180 millimeters per hour. So we have to design our pipes and our filters for this kind of intensity of rainfall. So therefore, rainwater harvesting also depends on the catchment area, the distribution of rainfall, as I have already mentioned it, the storage and affordability that we have to create the storage structures or recharge structures, and the recharge potential of the ground. How much can the ground actually absorb during these short spells of rain? Right. Now, one question which had come up, and this is not to read all these figures, was where do we get rainfall data from? The best source of rainfall data is the Indian Meteorological Department, IMD as it is called. It's a bit difficult to get data from them, but every city has a IMD center. It would be good for us to go there and get it. We may try and get it from the web, but it's not that easy as I find. But in states like Karnataka, for example, you have something called the Karnataka State Natural Disaster Monitoring Center. This KSNDMC, there's a website that they have, and they put out regular rainfall data, right? And KSNDMC is much easier to get granular data at even a village or a gram panchayat level. So for each one of our states, we have to find the equivalent of the KSNDMC, the Karnataka State Natural Disaster Monitoring Center, and try to see whether we can get rainfall data from them. But IMD is the more reliable, more significant rainfall information that we will get. One of the things that we need to understand is that rainwater harvesting is simple, but at the same time, we need a bit of mathematics to understand how to optimize the storage system. Again, you don't need to look at this graph. It's there as Excel. And for those who are really interested, I can share this Excel file. What happens is we have to design based on the rainfall distribution. Let's say if you pick August, 1, 2, 3, 4, let's say you get 4 consecutive days of rainfall. Then the total rainfall will tell us how much is the storage system that we have to create. But also understand that there's a consumption of that rainfall. So suppose there's 1,000 liters of rain that you're harvesting, maybe you're consuming 500 liters. So therefore, there's 500 liters available for storage. So it's a bit balance between demand and supply that we need to design our optimal rainwater storage systems. And I'll come to that a bit later. In terms of design, as designers, as architects, as engineers, we need to think of every roof as a catchment, right? Especially flat roofs that we are now designing need to be designed to be as clean as this. You should be able to eat off it. If you design the roof to be clean, and if there's luckily for us no tree overhang on it, then your runoff will be of very high quality. And that runoff will need minimum filtration, and when stored can last you a long time. But if the roof is contaminated, then that stored rainwater tends to go bad, and therefore we cannot use it for potable purpose. We may be able to use it for non-potable purpose. Important to design the roof as a catchment, right? And in the era of climate change, you can also design the roof with a white insulating paint so that it keeps your house cool. But remember that white insulating paint should not have any heavy metals in it. And there are many such paints available. So you do 2 things. One, your rainfall quality increases and quantity of runoff increases. B, the rooms below tend to be cooler than with other paints. So you can do a lot with rooftop design. Yeah. The second thing is storage. Now, storage is of many kinds. One of the simplest is something called a rain barrel. Here you see in a factory, the rooftop rainwater from a clean roof is coming in and is getting collected in these big syntax tanks, these HDPE tanks. This is the easiest form of storage. And what advantage you can see on the left is because the tank is placed on a high level, you can just put a pipe and draw water by gravity, right? So that's the advantage that we have. We can put above the ground tanks and store the water. And it's do it yourself and can be done very, very easily. Rain barrels can also be put on the rooftop, like the figure you see on the right. That's a small 500-liter rain barrel, which picks up water from the staircase room and collects it. And what Chitra has done is, Chitra Vishwanath, she's put in a pipe into the kitchen from this rain barrel. So in our kitchen, we are able to collect the water directly from the rain barrel and use it for drinking and cooking purposes. So if you design and put the rain barrel as high as possible on the rooftop, then you have the advantage of gravity. You don't have to pump water up there. You can use the water easily without any energy being spent. Now, if the roof is clean, and if you're doing a good job of keeping it clean, you'll see that the water quality is as in the center bucket, right? It's absolutely good, clean water. And I claim that I can differentiate between the Bay of Bengal and the Arabian Sea simply by drinking the water and tasting it and then telling you that it comes from the Bay of Bengal or the Arabian Sea. That's how good it can get. Yeah. So simple systems is the best way to go to begin rainwater harvesting. We don't have to complicate ourselves. Start small. You don't have to start big. You don't have to think of capturing all the rain that falls on the rooftop or on the paved area. Just start small and just try and understand what the quantity and quality of water is. On the right bottom, you'll see a small bottle, and that's called a H2S vial. That is for testing for bacteria. And that's a very interesting product developed in India itself, which for about 15 to 20 rupees can tell you if there is E. coli and fecal coliform. That is, if there is bacterial contamination of water. And so this is a very simple check for rainwater quality. And you can then decide whether you want to boil it or treat it or filter it before you consume it using the H2S vial test. Now, where is the H2S vial available? It's available online. You can go to Amazon, or you can go to the Development Alternatives website and be able to buy the H2S vials for testing the water quality. The other thing with rainwater harvesting is you can do different storages for different purposes. Yeah. So, for example, the rooftop rainwater that's being collected on the left is stored in a small drum there in the center, and that water is used for gardening purpose. The one on the right, you store the rainwater and you use it for the washing machine alone, right? And so washing machines, if you use eco-friendly soaps and detergents, you'll find that rainwater does a very good job of being very soft and therefore cleaning the clothes well and not leaving any marks on the pipes or anything. Many places. So you can distribute your storage systems for the purpose of use that you have, right? You can use some for drinking and cooking, some for watering the garden, some for washing and for bathing, and some for all other purposes. Yeah. So that's what it is. One of the other things that we find in the Indian context is that many dwellings have sump tanks, underground sump tanks, to store piped water which comes from the city utility 2, 3, or 4 times in a day, or maybe sometimes daily, but usually 2 or 3 times in a week. Now, you can use that existing sump tank, as you can see on the right, you can use that existing sump tank to also store rainwater. So during the rainy season, you close off the piped water supply from the city utility and just use it to store rainwater. And during the summer season, you use the city utility water. So rainwater becomes a supplement, and storage is the most important or the largest cost in rainwater harvesting. That is avoided because you're making use of an existing sump tank, which is for the city utility purpose. This also can be done well. If the roof is clean and if the filter is good, this common storage is one of the good ways of reducing cost with rainwater harvesting. Now, the other component is these downtake pipes. So you have PVC gutters, which are generally available in coastal cities where the rainfall is very high, Mumbai, for example, or Kerala and the whole state. You'll find plastic gutters, but in other parts, you just need these pipes. And the pipes are now becoming more easily available and of very high quality, which you then use appropriately. Make sure that it's food grade, right? That the pipes are food grade. And in apartments, like you can see in the left is Mohan, who's a plumber who's trained. In apartment buildings, you'll need to do specific design, especially in the parking lot, to collect all the rainwater and take it to a sump tank. As you can see on the right, it's now being cleaned up. The water, that's rainwater which is being cleaned, but that's the rainwater which is taken to a large sump tank or sometimes to a recharge well to store it. So you design the pipes, the pressure of the pipes based on the load which the water will bring. So suppose it's a 10-story building, then you'll need a 6 kg per square centimeter kind of a pipe thickness of adequate design. But if it's a normal house, then it can be a 4 kg per square centimeter pipe design. But some attention has to be paid to the design of the pipe. The first rain separator is one of the very important components of rainwater harvesting, because the first rain actually brings with it all the silt and dust. And even in subsequent rains, the first 2 to 3 millimeters of rainfall can bring a lot of silt and dust and leaves. So if you have a first rain separator, like the principle of the school is opening, you allow the first rain to go away, to drain away, and then you filter the rest of the water and then you store it, right? Now, this is manually operated. In some filters, you can get it to be automatic also. That's an automatic first rain separation. But designing a first rain separator is crucial to improving the quality of the rainwater that we get. Filters themselves can be basic do-it-yourself at many scales, small towns, village levels, large gram panchayats, or in the periphery suburbs of the city. You can make your own filter, using charcoal and sand and gravel, and you just filter the water through that and push it off. Or as in the right, you can simply use a used pair of socks and a dhoti as a filter, and that will do a very good job if the rooftop is clean, right? So you don't have to really worry about how good the filter is if your rooftop is clean and if you have a good first rain separator. Or you can do improved versions of these filters using charcoal, as you can see on the right. Charcoal is a good adsorbent of gases, and charcoal also cleans water. And with a bit of lime to balance the pH of the water, you can get good filtration water, which is also improving the quality. You also have more than 40 different kinds of ready-made filters available on the market. You can buy it online, Flipkart, Amazon, all do it. Of the two that I have personally used, which is not a brand marketing, but the one which is called Farmland on the left and the other one called Knee Rain, I found to be very good. They've worked on product design and improved it a lot. And the one on the right is a very easy filter, which I've used a lot. But remember, in these filters, there's still a lot of wastage of water because some of the silty portion of the water tends to go out of the filter, whereas with the do-it-yourself kind, there's a lot less wastage of water. But these options are available to you, and you can just buy it off the shelf and put it on. So here in the school, you have a masonry filter on the left, which is a do-it-yourself kind of a filter, and it goes into a sump tank. And on the right, you have these product-based filters also in the school. So you can try out both wherever you want to do it. And then this filtered water is stored in a sump, and from the sump, it goes to a recharge well. And I'll talk to you about a recharge well, where the teacher is explaining to the students how a recharge well performs, what an aquifer is. So rainwater harvesting systems become great knowledge centers or knowledge places. Now, recharge is a very good mechanism in the Indian context, especially where you have dug wells or open wells. In many cities, we have dug wells and open wells. Mr. Balasubramaniam here is demonstrating how rooftop rainwater comes through a small blue drum filter, which is a charcoal filter, and then goes to that blue blue tarpaulin cover, which is a 40 feet deep well. So he puts all the rooftop rainwater, about 2.5 lakh liters of it, into the well, and his well then provides him all the water that's required for him throughout the year, right? So recharging wells is a good way of managing water if the aquifer conditions or the groundwater conditions are correct, right? So that's another recharge well. Here, it doesn't occupy much space, can only be 2 feet in diameter or 3 feet in diameter, and you can go 10, 20, or 30 or 40 feet deep, depending on the soil profile, yeah. So based on the rainfall patterns and the recharge conditions, cities have evolved their own bylaws. I have been privileged to be working with Bangalore and looking at the rainfall pattern in Bangalore. The bylaw says that for every square meter of roof area, create a 60-liter storage or recharge. And for every square meter of paved area around the building, create 30 liters of storage or recharge. And then it says that the minimum depth of the recharge well should be 3 meters. That is to go below the hard profiling or the clay layer of the soil so that there's more percolation, right? So simple bylaws can be created based on the rainfall pattern, and you'll have to look at your city and see what bylaw it has created and then follow those bylaws. It'll help you do the design better, right? And then how do you dig recharge wells? Here's the well diggers holding the soil from a recharge well. This community, which we have been privileged to work with, are a traditional well digging community who've been digging wells for 1,000 years. So there's the social construct of water also in the Indian context. And the social construct of water is very interesting if you want to find solutions, because these well diggers know the lay of the land, know where to dig, how deep to dig, how to dig safely, recharge wells and dug wells, and we can use their knowledge, traditional knowledge, to do rainwater harvesting systems better, right? So here's how they dig a recharge well. A team comes, 4 to 6 people. They mark a hole in the ground. They dig up to roughly 30 feet, as you can see in the center, and then they put in place precast concrete rings, right? Like this. These are precast concrete rings, which are locally made and it's available. They have porous holes in them, and they line the wells with it. And then all the water that is from the rooftop can be filtered and led into it, or from clean stormwater drains, like where there's no sewage flowing yet, where there's no garbage in it. You can redesign stormwater drains to pick rainwater and push it into the recharge wells. You can see it on the left, where you've created baffles to store water in the storm drain, or on the right, where a small recharge well has been connected to a stormwater drain and filtered water is let in into the recharge well to recharge the ground. And this particular well, for example, puts in 1 million liters annually into the aquifer, right? And so many campuses do these kind of recharge wells. You see a safety grill on top, designed to take the runoff. And remember, these should be not heavily frequented roads. There should be no oil spillage. There should be no sewage or stormwater or solid waste dumped anywhere around, right? And you can then design the recharge wells appropriately, even within the storm drains itself. Like, as you can see in the center, there's a recharge well in the storm drain itself. There are other forms of recharging the aquifer, which is not the shallow aquifer. It may be the deeper aquifer. And this I will not dwell too much, because I think Kalpana will cover this a lot more. But then you have to make a boring about 100 to 200 feet deep and have a perforated casing and allow water to go into those kind of recharge structures. Now, recharge structures are dependent on geology and the soil profile and have to be designed appropriately. How do you do it at a gated community level? Pick this gated community, for example, 36 acres, 360 plots. What they have done is they've banned individual bore wells, but they've made recharge wells mandatory. So every plot has recharge wells in it. And so the 360 recharge wells are putting water into the ground, and only 3 community wells are taking the water out, which means that by sharing and communitizing rainwater, by making recharge mandatory, and by drawing only that much water that has been recharged, you draw up a water balance and you become water positive. Yeah. And so this is the maths behind it. Just take a look at the bottom right number, the 2 numbers in blue. Net annual groundwater overdraft before rainwater harvesting was done was 32 million liters per year. That is, you were drawing 32 million liters more than you were recharging, and wastewater, 79 million liters, was just simply being disposed of. After rainwater harvesting was done and treated wastewater treatment plants were set up for recycling, the net annual groundwater draft is actually -2, meaning they're putting 2 million liters more into the ground than they're drawing from it, and all the disposed water is being reused for non-potable purpose, right? So at gated community levels, rainwater harvesting can make the community completely independent of city level requirements, and also make sure that they recharge more than they draw so that groundwater tables don't fall, right? So that's possible. And so this is another gated community of 220 acres where we've designed rainwater harvesting system. Now, this is a large dwelling with large plots, what they have done is they've done recharge wells and tested the recharge wells for the recharge rate. What you see in the figures number 4 and 5 is a certain volume of water is put into the recharge well, and then it's measured as to how long it takes for the water to percolate down. Like you find these numbers 2:30 p.m., 3:30 p.m., 4:30 p.m. How much time is it taken? We calculate the recharge rate and we're better able to design recharge wells. Now that's a given. The recharge rate should be at least 2,000 liters per hour. Then in that case, you can design adequate number of recharge wells. What that has meant for the gated communities, when they have put in recharge wells all across in the upstream area, the groundwater table has come up, and these traditional step wells which have been restored now provide all the water that's required for the community. You see the dilapidated well there, and it's been restored there, and this now becomes a feature of the landscape. But it's also functional in the sense that all the water required for the 220 acres can come from this one single step well also. And as I was mentioning to you, you check the water quality using H2S vial for E. coli identification and make sure that the water is potable, or you take steps to make it potable by filtering it, treating it with UV or treating it with RO if necessary before it's consumed. But for non-potable purpose, you can use it without anything. So bylaws and regulations are now kicking in most cities, and these bylaws and regulations need to be understood and read before we implement rainwater harvesting in our cities, right? And there are fantastic things like in Gujarat, where they collect rainwater only in the month of August. It's called Magh Masa or Magha, and the rainwater itself is called Magha. This is near Lothal, where I was privileged to see. They have a pipe and they collect water in some tank and use it for drinking and cooking throughout the year, because the water there is otherwise saline. They make sure they store about 10,000 liters and only use it for drinking and cooking purposes, and that lasts them a year and sometimes 2 years. The final point that I want to make is that community structures like schools and hospital buildings are great places to do rainwater harvesting. Like so, you make rainwater harvesting designs and you make sure that there's filtration and recharge and storage also. And then you put in place water efficient taps with aerators so that children understand the value of water, how to conserve water, and how to use less for hand washing. And you can build eco-sand toilets, but I won't go into that right now. But these are sort of crazy things that you can do with water management at a household level. And you can read up about eco-sand toilets. It's really nice. And you can reuse grey water also. Now, all these are components of making rainwater last longer. By building eco-sand toilets, water efficient taps, grey water recycling, you're able to extend the stored rainwater, because freshwater demand comes down dramatically. And metering is crucial in all our flats and apartments, especially if you have a water meter. If you know how much you're consuming, then you can take measures to control usage and reduce the consumption. Demand management is key, as I was showing you in the list of 7 pipes, right? So this is what we need to work on. And finally, this journey of water literacy is first we become water literate, and then we spread water literacy by teaching students the quantity and quality of water available in their environment, the demand being put on water, for example, for agricultural use, for industrial use, and for other commercial uses. And with children together, we create a society which is water literate in the context of India's water crisis, where rainwater will play a major role. Here, my colleagues are giving a rain gauge to the principal. The students will measure rainwater every day in the monsoons at 8:30 a.m., put it on the notice board, calculate how much water the school has got, calculate the quality of the water, and for themselves, each one of them become aware of how precious water is and how precious rainwater is and how you can go about it. So that's the great journey that you're also beginning, and hopefully you'll be part of it.